Hello, welcome to the session on Design of Machine Elements 1. Myself Bindu ME, Associate Professor, Department of Mechanical Engineering, Luz Mada College of Science and Technology. In this session, we will see the introduction to design. We will see this design, engineering design and machine design. So first let us see the basic definition of design. Design is essentially a decision-making process. If we have a problem, we need to design a solution. In other words, to design is to formulate a plan to satisfy a particular need and to create something with a physical reality. So we have to emphasize on these words, that is decision-making process. It is essentially a decision-making process. And problem and solution. That is, we are having a problem and we are finding a solution for that problem. And the solution is something with a physical reality. So let us take an example of a chair. You are asked to design and manufacture a chair. What are the questions coming in your mind? You can consider a number of things, and the first one is it for a kid, or is it for an adult, or for an elderly person? So if it is for a kid, the safety is a primary concern. You can make the chair using different materials such as wood, metal, plastic. So for a kid, we can use plastic. It will be safe. Then the color of the chair. Kids will be attracted to bright colors. So you have to consider that also. So if it is for an adult, the strength is a major factor. And for an elderly person, comfort is a major factor. So in all these cases, you have to consider so many things, and you are asking questions to yourself, and you are coming into a conclusion. That is a decision making. And finally, you are making the chair which has a minimum cost of production. So here we are having a number of parameters. Here it is safety, material, color, and here it is size, shape, strength, and here comfort. Final, it is manufacturing. So the factors can be: 1. The purpose for which the chair is to be designed, such as whether it is to be used as an easy chair or an office chair or to accompany a dining table. Then whether the chair is to be designed for a grown-up person or a child. Then the material for the chair, its strength and cost need to be determined. Finally, the aesthetic of the designed chair. So these are the factors which can be considered in this basic design stage. Now let us see the engineering design. It can be defined as the process of applying science and engineering methods to prescribe a component or a system in sufficient detail to permit its realization. Let us again take this same example, chair. Here we have considered some of these parameters and we have designed and we have manufactured it. So if we include this engineering design, what is the difference? Here we are bringing science and engineering into the design. For example, we can consider the design, the forces acting on the legs of the chair. What is the maximum stress produced? Will the legs will be having sufficient strength to withstand the force acting on it? So for this, if it is necessary, we can use the simple stress equation, that is sigma, that is stress is equal to force by area. And considering all this, if we design and realize this chair, then we can say that it is engineering design. Now let us see machine design. A machine is a combination of resisting bodies with successfully constrained relative motions, which is used to transform other forms of energy into mechanical energy or transmit and modify available energy to do some useful work. If it converts heat into mechanical energy, we then call it as a heat engine. So I have taken an example of a car. Now let us see how this car engine works to understand this concept of machine design. So this is a multi-cylinder, that is a 4-cylinder engine. This is a working. We are having a number of components here. In this, the engine generates the power from the expansion of compressed air and fuel inside the cylinder, and this power is generated. The main parts of the engine are: 1. It is a cylinder. Then we have this piston. Then we have this connecting rod. We have this crank and crankshaft, which converts the reciprocating motion of the piston into rotary motion. Then we have this inlet and exhaust valve, and these are driven by the two camshaft. One camshaft, you can see it here, one is on the other side, and these two camshafts are driven by the crank itself. This is connected through a belt. Now we will see this in detail. So this is a working. So this is a crankshaft we are having. Then the piston and connecting rod. Then we have this inlet and exhaust valve, and these are connected using a camshaft, you can see here, and this is connected to the crankshaft using this belt. So we are having different components. All these components are designed and manufactured separately, and all these are assembled to form this. So you can see that a power is generated in this engine. Here we have 4 strokes, that is intake, compression and expansion and exhaust stroke. So only power stroke produces the power. Then how engine turns continuously? Well, that is why we are having this flywheel here. You can see a flywheel here. So this flywheel, it provides the momentum which prevents the crankshaft from stopping immediately. So here it is a 4-cylinder engine arrangement. So in any time instant, one cylinder is always in the power stroke, that is producing a power stroke, and this produces a power stroke, power, and also less vibration compared to a single cylinder engine. So this is the 4-cylinder arrangement we have seen. And let us see a working of a single cylinder. This is a spark plug. Then during this inlet stroke, this valve opens and the fuel is air inside this, and it is a compression stroke, and then we have this expansion and finally the exhaust. So this is how the engine works. So here we have seen that the engine is having a number of components such as connecting rod, piston, cylinder, then the crankshaft, inlet and exhaust valve, then camshaft, then the belt. All these components are designed and manufactured separately, and we are assembling it together, and it is functioning, and we are getting the power output. So each component is having a relative motion with respect to each other. So this is machine design. We are designing all these components required for a particular operation, and we are assembling it together to produce the final output. So that is about this machine design. Thank you.